Hello everyone and welcome back to this online NPTEL course on aquatic geochemistry. We are discussing the freshwater chemistry in this particular module, and in today's lecture we are going to look into groundwater compositions. Now groundwater composition is controlled by, first of all, different, it is a complex system, but we can narrow it down to three proper dominant controlling processes and pathways. Okay. So, the first component that is very important is of course the water itself. So, where is the water coming from? So, the water coming from is getting stored from precipitation. Okay. So, whatever the rainfall gets infiltrated into the soil system, it gets it goes into the soil, it goes down it deeper and deeper, and then in the ground you have two zones. You have the unsaturated zone and you have the saturated zone. So, in this unsaturated zone the water is dispersed, but in the saturated zone most of the the pore spaces are completely saturated, and beyond the saturated zone you have what is it called the aquifer. So, below the saturated zone you have the aquifer where basically the water is flowing. Okay. So, this first one we talk about is when we talk about the rainfall. Okay. So, groundwater composition, its first hand control is the rainfall itself. So, what is the composition of the rainfall, and not only the rainfall, what is the geology of that area, what is the soil composition of the area. So, that controls the first hand composition of the groundwater. Now, since rainwater composition and the the petrologic, what is petrologic and mineralogic composition. So, what types of rocks it is? It's an igneous rock type, is it sedimentary rock type, is it metamorphic rock type, what kinds of rock it is, what kind of soil it is, whether it is a black soil, whether it is a red soil, whether it is alluvial soil. Based on all these parameters we come to and we get to know our groundwater composition. Okay. Now, if we look into the minerals, okay, you can see in this image that minerals are commonly divided into two types of minerals. The first type is the reactive type and the other is the non-reactive type, right. So, any mineral we have to first understand which type it is. Will it be very reacting with water or which is of non-reacting type with water? That means it is a very stable phase. They do not have any kind of weak bonds or anything like that. That means it does not readily interacts with water. Yeah, now if you break it down or you give it different kinds of temperature and pressure and heat and everything, then it may start reacting. But this non-reactive in nature means that under normal conditions of the earth's surface environment, these particular minerals is not going to react too far. For example, what do we have in this in this class? We have quartz, we have rutile, we have zircon, magnetite, spinels, ilmenite, kyanite, titanite, tourmaline, garnet. Now, some of these minerals are very hard type of minerals. Okay. For instance, we have zircon here, we have quartz here, we have tourmaline here, we have garnets here. So, in this group of minerals, they are of the more hard, they are the more refractory minerals. Okay. So, these minerals are it is not going to be a lot reactive. Okay. So, they are very stable, they are their bonds and magnetite and spinels and all that, they are very stable structure, their stoichiometry structure is very stable. So, therefore, they fall under the non-reactive category. The other which is our concern is the reactive category. Okay, and that again can be divided into two kinds. One is the simple, simple stoichiometry is there. That means it entirely goes and it can just get entirely solubilized in the water, and it's very simple. It's follows the stoichiometry laws and all that. The other one is the one with more complex stoichiometry. That means it is now having other parameters that can determine its solubility. Even under that category, we can differentiate between those minerals which, when reacts, there an equilibrium is possible, and another set in which equilibrium is extremely less likely to be possible. Okay. For instance, we have under the equilibrium category, we have kaolinite, we have dolomite, talc, kerolite, zeolites, alunite and jarosite. Now, all of them, so why they are complex? Okay, why are they not very straightforward? They might be due to there can be many parameters. Okay, so what it means is these minerals, they have very high solubilities. So, for instance, kaolinite, dolomite. Okay, they are, so kaolinite is a type of clay mineral, dolomite is a type of carbonate mineral. So, they are very easily soluble. Okay, they are reactive, they are soluble, and they go into immediately they will start reacting, as compared to the other group, which is feldspars, amphiboles, micas and all. These group of minerals, they are more of the hard mineral types. They will react, of course they will react, but here the entire they are not going to completely dissociate and completely they are going, these are the mineral types which is going to weather and produce what is called secondary minerals. Okay, they are going to produce secondary minerals. These are again products, these are actually the secondary minerals. They can be of the secondary or primary. Okay, kaolinite is a secondary mineral. Okay, dolomite is also a secondary mineral. Okay, it can be both primary or a secondary mineral. Okay, now these feldspars, amphiboles, micas, they are going to give rise to more and more secondary minerals. So, their compositions, they are very complex. Okay, what will you find in their structure can be very difficult to determine. They can, some of these feldspar can have a lot of impurities. Okay, so there can be other metals, ions as impurities in the structure. So, therefore, we say that these have a complex stoichiometry. Okay. Then the other group, which is called the simple stoichiometry, right. So, these are the minerals which is going to very easily be soluble, easily dissolve, okay, will not give rise to some other kind of mineral type. It may give rise to some other mineral type, but more or less it is these are all either phosphatic groups or sulfate groups or carbonate minerals, and they are going to be solubilized very easily. So, these mineral types, these are easily going to react. They may produce some secondary minerals, but they are more likely to just simply dissolve. Okay. And among them, here are certain types of minerals which are extremely important. For example, if you have halite in any of your formation, if you have gypsum in any of your formation, if you have calcite, fluorite, these kind of mineral types, they are going to dominate the chemistry. They are extremely reactive, they are very simple structure, they are going to readily be solubilized. So, if in the if the catchment, if anywhere there is calcite, if there is halite, if there is gypsum, any kind of other evaporite mineral type, okay, so they are going to go to solution very easily. And even if the rock contains only 1% of these minerals, 99% something else, only 1% of these minerals, even then their dissolution is going to define the water chemistry, because these are the most easily soluble minerals, and even if the 1% entirely dissolves, they are going to control the water chemistry. So, other than these very important and soluble minerals, we also have silicate and anomosilicate rocks and their minerals, which are mainly of these types, who has far less solubility and the rates of dissolution is very slow. Okay, their rates of dissolution is very slow. Okay. So, their contribution to the water will be over the long term. So, the more aged the water is, more concentration of minerals it will have. The more younger the water is, it will look more like precipitation. Okay. Of course, soil is there. So, soil will contribute a lot. In fact, soil contributes a lot of the dissolved nutrients and organic matter, and a lot of the oxygen and pH that is controlled by soil. So, when we talk about groundwater, we always think in terms of soil, what is the soil that is there, what is the rock that is there, and of course, rainwater, we commonly, at least we have some understanding that okay, it will not be so off. Okay. So, the main dominance will come from the soil and the rocks. Then there is a third factor that comes in, and that depends again on the geology and the rock types and the properties of the formation. That means how the water and the rock is interacting in the system. Okay. So, this depends on the porosity of the system, this depends on the flow of the water through the entire system, through the soil, through the rocks and everything. So, if the soil is very coarse grained, if the rock has a lot of if the rock is made up of a coarse grained type of structure, and if it has a lot of fractures and it has many, so it has points that allows the water to infiltrate very quickly, to interact very quickly, then we call those type of aquifer rocks that allows high velocity. So, we have that high groundwater velocity. So, infiltration, rate of infiltration is very high in these types of aquifers. So, it can be made up of limestones, or it can be sands and gravels and all that, or it can be very highly fractured. So, if it is like in a metamorphic zone where there is a lot of fractures and cracks and all that, or if it is igneous rock and there are all these dikes and sills which also generate a lot of fractures, then the groundwater can just the rainwater can just percolate along these fractures and reach to the aquifer. What happens is that then these become the shallow table, the shallow water table aquifers. Okay. They are not in deep. So, they are not the deep confined aquifers, they are more of the shallow water table that you see in between two impermeable rocks. So, the high velocities imply that they have a thermodynamically open system, because water is continuously coming in whenever it is raining. So, it becomes like an open system, and it also can get removed very easily. That means they can get connected, they can move to the deeper groundwater. So, the residence time in the shallow water table can be low, and if there is human abstraction is going on, then this is the first water table that you come across. So, if you are digging, the shallow water table is what you first going to come across before the deeper water table. So, there is a shorter residence time in the water table, and there is a continuous supply of fresh recharge. Okay. As the recharge is happening, there will be more and more supply of fresh water. Chemical weathering in these kind of systems is very active. Okay. It will be very active. There will be very few secondary minerals that reach saturation at such high water rock ratios. Okay. The water is more as compared to the rock. Okay. So, this is called the high water rock ratio, and they are, since the water that is coming in is always fresh and again it is moving out, saturation is never reached, equilibrium is never reached. So, you are just moving, you are continuously moving things. So, therefore, it is a very active system. Just the opposite of this is the low velocity kind of a system, where you have the rocks are very impermeable. Okay, that means they are very compact. Okay, the sediments, if they are sediments, then you will see that they are extremely compact sediments, and they do not have any fractures or cracks, and the hydraulic gradient is very close to 0. Okay, this is what will happen then. Then the water that is flowing is, it's going to have a very long duration. It is going to be in this zone for a very long time. So, there will be very long residence time. It is more rock dominated. Why? Because the fresh water supply is very limited. Because of these impermeable rocks, the fresh water supply gets very limited, and since the water itself remains into the system for a very long time, we see we are going to see more and more higher TDS, and the minerals in the rock are in chemical equilibrium. That means, due to the long interaction time, the minerals are going to be in a they are in chemical equilibrium with the groundwater. These groundwaters, they have higher TDS and they are more of the saline type. Because of the long duration, in the aquifer, they are going to be more and more saline. But this is again dependent upon the kind of geology that you have. Okay. The geology of the catchment is extremely important for groundwater composition. Okay. So, very important to know what kind of rocks that we are seeing. Now, let us see some chemical properties, the differences between an artesian, that is a confined aquifer, and in an unconfined aquifer. Okay. What do you have in an artesian condition? Artesian condition means that there is 2 layers of impermeable rocks, and you have the water table in between these 2 impermeable rocks. Okay. So, this is an impermeable layer, this is an impermeable layer, and you have the artesian water table. Okay. In the normal water table, what happens is, you have the soil layer and you have the regolith, then you have the saprolite, okay. You have the regolith and all that. So, then comes the water table, and beyond this water table is also the bedrock. Okay. Beyond this water table is also the bedrock. So, the bedrock is absolutely impermeable. So, there is no fracture, there is no more water, maybe some interactions is going on, but it is mostly limited to the surface and some cracks if that exist. Okay. So, this is only one surface is impermeable. Okay, one impermeable substance, but in artesian wells what happens is, due to the formation of the aquifer, sometimes there can be clay lenses. Okay, there can be clay in between the formations, and there can be many types of artesian wells. You can go ahead and look into the details, but what these kind of wells are is that they can vary in depth, but they are confined, okay, by 2 sets of impermeable rock types. So, what are the differences we see? So, they have a nearly constant head with time. Okay, since they are, if you dig a well here, you will see first they are water is going to rush up because of the sudden pressure release. Okay, and their head is going to be remaining constant if you are not extracting water. In the other kind of water table, what is going to happen is, it is going to vary with the season and recharge events, because the water will pass through the regolith and the soil, and it is going to come and infiltrate into the water table. So, the season and the recharge events is going to control what is the water table height. Okay, what is the water table height? The next thing is oxygen. In artesian wells, oxygen is usually below detection, because these are confined structures. There is no exchange of oxygen, there is no more fresh water entry. So, it is very oxygen is almost depleted, it is well below the detection limit. Oxygen in other type of water table, non-artesian kind, is always near saturation. Okay, it is always near to saturation because of its continuous replacement with the fresh water coming from the top. Here the pH is usually near 7 or higher. So, more alkaline type. Why? Because of the impermeable rocks that you are having, they are interacting. Okay, more and more rocks are going to interact. So, the alkali elements and everything, they are going to come into the solution, they are going to make the system more and more alkaline. All the carbonate minerals, they are going to be there. So, it is going to be rich in carbonates and bicarbonates, right. So, they will have a pH which is more of the alkaline nature as compared to the water table, which has more rainwater coming in. Rainwater is slightly acidic, right. So, because of its high contribution from continuous rainwater, therefore, its pH will be slightly low, okay, close to 7, and sometimes if the recharge rates are very high, then it can even go down to the pH level of the rain. So, water tables which are having more shallow, more high recharge rates, they reflect the rainwater pH as compared to the artesian wells. The nitrates are very low in the artesian wells as compared to the water table found in non-artesian wells. Why? Because these nitrates, they are coming from soil, right, they are coming from soil leaching. Agricultural land, they are going to leach the excess nitrates and other kind of nitrogenous compounds, and they are going to form nitrates. So, in this artesian well, since they are confined, nitrates are not as readily leaching in continuous supply. Even if there was, with the long time residence time, it can eventually degrade and get released as nitrogen gas. Nitrate is always present in shallow water table because of the continuous entry of rain. Rain is acidic, it is going to dissolve all the ammonium, salts and all that is there in the soil, plus the rain itself is going to have a lot of nitrates because of the atmospheric deposition. Then Fe as Fe2 may be present because of its reducing conditions. Because of the lack of oxygen, iron can be present as iron 2, whereas in the oxygen rich, in the oxic water table, iron will be mostly be precipitating out, and you will see that Fe2 plus is very low in concentration. In the artesian wells, they will have gases. There can be hydrogen sulfide, there can be methane, some other gases that can be there, which is getting released due to long term decaying processes, and it's just trapped, and if you are just releasing it, you will see certain peak of gas and then it is going to stop. Similarly, in water table there will be no such, there is no reducing zone. So, there is no hydrogen sulfide being produced or methane being produced or hydrogen being produced. Then the temperature of that particular water system in artesian wells remains almost constant. So, the constant composition and constant temperature is a very common reflection of deep well, of a deep groundwater or artesian well water. Because in water table what happens is, as you go down, as you are changing the depth, there is a lot of change. So, there is a lot of temperature difference, there is a lot of compositional difference. Okay. then many minerals are at their saturation state because of the long residence time in artesian wells. We have nearly constant, we have the minerals, they are very close to its saturation, and due to this the TDS is also going to be very high in the artesian well type as compared to that water table in shallow, from shallow aquifers, they have relatively low TDS, okay, and the fewer minerals are at the saturation level. Okay, they are not that saturation level, there are shorter residence times, there is a lot of weathering that is happening. In artificial wells again there is constant or near constant stable isotope composition. What do I mean by that? That means the water, since it is there for a long time, the the composition remains quite constant as compared to this other, normal shallow water table, where there is more flux of fresh water, of rainwater and all, and they are continuously getting, mixing of the water with the new fresh water. So, there is a lot of compositional variability expected. If you want to date these kinds of water will be old enough in the artesian wells to be dated with respect to tritium if the water recharge rate is within some tens of years, and if it is more than that, if it is a very deep well and the recharge rate is very slow and it is thousands of years, you can use 14 carbon dating. Okay. Sometimes we are going to use a mixture of isotope systems to understand, okay, which range of dates is expected. Water table, generally shallow water table, the water can be very fresh and it is very young, it can be just a few days old, and it is able to be dated by tritium. So, tritium is a very useful system specifically for shallow water table dating, and if you have artesian wells and water tables in the same area, the shallow water table will have water much younger and fresher as compared to the artesian well. Now, what are the threats to groundwater and its quality, its quantity? So, when I say groundwater, I mean both its quality and its quantity. Okay. So, these two terms, that is what quality and quantity, okay, as discussed yesterday, are interdependent. Okay. So, you cannot have something which is of big, very big quantity, but and it will not affect its quality. So, the quantity of water definitely affects the quality of the water. So, let us look into some, why we are worried about groundwater, what are the main challenges that we know. So, let us begin with the very the first fact that I would like all of you to know is that India is the largest groundwater consumer in the world. India itself consumes almost 1/3, so 1/3 of all groundwater on earth is consumed by India. So, we as a country, we are hugely dependent on groundwater system for our municipal works, for our agricultural, for our industrial, for every kind of water, we are heavily dependent on groundwater. And as we have, as we are talking about water issues and all that, so over extraction is the biggest problem in terms of groundwater. I mean, if you just if you need to know the one problem related to groundwater, you should know this, and that is over extraction and depletion. Okay, we are taking out water at a rate faster than which it can rejuvenate, it can recharge. So, what we are now seeing is that almost entirely in the country, we see depleted levels of groundwater, except just a few patches of areas, specifically in the northeast, or in the northern areas, a couple of zones specifically in the eastern Himalayas, that area, because it receives much higher rainfall. Similarly, area just around Mumbai, that is also showing normal recharge rate, but except these few patches, the entire country is facing far below average recharge rates, and the water table is rapidly declining. And you can commonly ask, I think it's a very common knowledge. If you ask people around, you will know that okay, the water was available here at 200 300 meters below the depth, and now we are digging up to 800 meters 900 meters to find groundwater, which is like 3 times more we have to dig it up to find the same groundwater. So it's over extraction, there is no recharge, so it's all combined. Okay, so there is very high pressure, and what is more important is to understand that this water scarcity, what we are talking about, is very localized phenomena. What happens is we are all trying to live in the we are all trying to live in a city, and we are all getting localized, right. So if you see in India, all this all the time we are going to hear when will be ground zero day for Bangalore, or when it will be zero water day for Chennai, when will be zero water day for Mumbai. What does it mean for that? So ground zero day means that there is no water available for anybody. For instance, such a day came in Chennai when Chennai was suffering through a lot of water problems. People did not have water even for drinking. So the mineral water and all these kinds of waters were later on supplied. It was supplied from other areas. Water came in through tankers and railways and everything. So this is the kind of situation that happens because of the kind of localized problems that we have. That means due to growth of cities, the urban areas, certain pockets of land, they become extremely rich in population. So these places, they are rich in population. There is a lot of urban development going on. So urban development is going on. When I say urban development, what happens is that the land use changes, right. So where it was just soil and the recharge was happening, now all of that has been concretized. Okay, there is no more free land available where the water can pass through. So concretization or urbanization and construction of all urban infrastructure, all this is going to lower the recharge rates in these areas. So what are we having? We are having here higher demands, but we are seeing lower recharge rate, and this population is continuously increasing in this area, not by birth but mostly by immigration, right. People are continuing because of their socioeconomic conditions, they want more jobs, they want better lifestyle. So due to the socioeconomic changes, certain cities we see very rising populations and rising urbanization, both of which are changing the land use change and their concretization. So there is depletion happening. Okay. What is also happening is that irrespective of where you are, wells are being constructed. Okay. You may not know how and where to construct a well, there is no such consultants. So people wherever they want, they are just digging wells. Okay. So there is poor management of groundwater in these areas, and there is lack of well construction strategies and their maintenance. Okay, so sometimes it so happens that you have a shallow aquifer and you have a deeper aquifer, and a person is digging a well, okay, and they are mixing both the shallow aquifer and the deeper aquifers also. So any day, anytime the shallow aquifer gets contaminated, then the same shallow aquifer is going to get contaminated, it will contaminate the deep aquifer as well. So this is called what is poor kind of well construction. That means we do not have any idea what the well was supposed to be constructed. We just randomly start digging, saying that I want water, and the maintenance is also not maintained. The wells are not maintained, they are not cleaned regularly, they are not maintained, the infrastructure is not maintained, and therefore it can lead to a lot of serious issues. What other kind of issues do we see? We see something called groundwater salinization. That means near to the coastal areas, what happens is if the groundwater level is falling, right, if the groundwater level is falling, so this is the older water level. What happens is if the groundwater level is falling, then the sea water is going to come and enter into the aquifer, and you see this phenomena in almost all coastal areas. If you go to near to any coastal areas, you will know that there are certain wells which always have salty water. Okay, there are certain wells which are always having salty water. That means they have continuous salt water coming in. So there will be some other wells which will have timings of salt water and fresh water. That means whenever there is a high tide, whenever there is a whenever the sea is progressing towards the land, then there will be salt water intrusion. Okay, and specifically in deltaic regions, this is very common phenomena that twice during the day the salt water will come. If you go and collect the water at that time, you will collect basically salty water. Okay, because the other time of the time, what happens when there is low tide is happening, then the sea water is going to get, it will regress. During this regression, it will also come out, its influence on the aquifers will be low, and the natural fresh water will again come into the wells. Okay. So, these kind of wells will have certain timings depending on the tide about when it is having fresh water and when it is having salty water. And of course, there will be some wells which will continuously have fresh water. Okay. These wells may be of the deeper, they are generally of the deeper groundwater, and they are so well confined that the pollution has still not touched them. So, the fresh water is still coming from them. Now, groundwater salinization is a huge problem, and it can be due to multiple reasons. So, we will be discussing them in the next in the next lecture. We will be discussing this in more details. So, with this I stop today and see you in the next lecture. Thank you.